on a phone, it seems that they believe that there is a never-ending series of confirmations, and the more the merrier. Once upon a time, you could do a navigation and just click, navigate. You could just search for an address or click navigate. Now you have to say yes, yes, yeah, I really want to navigate. And the same for broadcasting. Anyway, sorry. Yeah, thanks. Okay. So anyway. Yeah, so JavaScript, doesn't have anything to do with the Java. There is a story about the naming of it, but I don't know it, and I forgot it or so. So you can get started in various ways. You can use either Firefox or Chrome Developer Tools or Firebug, which is a browser extension, or you can use a Node.js command line. The way I do, if I want to code in JavaScript, is simply this. I take any window and I say View, Developer JavaScript console. This gives me the JavaScript console for this page, which I don't particularly care about, but I can clean it if I want, and I can also pop it out so that I can see it in all its honor. Okay, so this gives me a place where I can type JavaScript comments. So for example, I can say var h is equal to hello. Okay, undefined means that the statement I've written has undefined value because it's an assignment which does not produce a value. Okay, but if I say h, it tells me, oh, the value of h is hello. Okay, thank you very much. Okay, so this is how you can play around with the JavaScript quickly. Okay, and if you instead have JavaScript loaded inside a web page, I think it would be more interesting actually for me to show it to you using this page. Which page? This page. Okay, so this is a real page that does a lot of complicated stuff. I didn't write it, by the way, this JavaScript. Okay, so I don't know what it does. But if I go in the JavaScript console, okay, so in this case it doesn't give us a lot of information, but there is a way in which the web pages can actually send the log information to the JavaScript console. So if you develop, it's one of the problems when developing is always, where do I do my prints? If you are using Web2Py, I gave you for homework 3, and I highly recommend that you look at it, some way of logging to the console of the server, right? And if you write on your own server, then that information goes, if you use your own server, that information goes to the console of that isolated server. If you write it in the cloud, as I will explain, you will get it in some logs that can be aggregated for all the various servers you might have. Okay, I will tell you how to do that later. But if you are in the browser instead, and if you are developing, if you want to do the equivalent of printing, there is a way to do it on this JavaScript console. So you see error pages and other information coming from the application. Okay. On this page. So here, this page is not printing anything, but whatever. Sorry, I need to find, okay. So what are the basic data types? So I'm sorry, the font is a bit small. I cannot modify it very much, but so when you use a programming language, you always wonder, okay, fine, what can I do? What are my basic ingredients? What are my basic data types? Well, not surprisingly, there are numbers, there are strings, and there are booleans. And the booleans are like Java booleans, that is, they're lowercase, just to make it easier on us. Some of them are upper and some are lowercase, just to add to the confusion. And you have operators like plus, minus, divides, and Boolean operators that look like the C ones. So the and is ampersand, ampersand, the or is vertical bar, I don't know how to call it, pipe. I'm not quite sure how to pronounce that. But you have, sort of the basic operators are there, thankfully. So you have variables, okay? For example, sorry, yeah, this is a way to declare a variable. Var h is equal to hello, and or I can say h is equal to h plus there, okay, and the value of this is hello there. Okay, fine, great, very very deep. You see, I declare variables with a name, with the name. I mean, by using a var for a variable declaration. Okay, so of course, I, like you, will make a lot of mistakes because you know, in Python you don't need to declare variables; you just create them by assigning a value to them. And here instead you need to say var to create them. So you have to sort of remember these. Then you have some built-in functions, math.max, to uppercase, to lowercase. Another one that is often useful is parse. You see, by the way, that this is kind enough to give us completion of all the possible functions. So this sort of helps us explore the language as well. But for example, parse float of 45.2 inside a lot of spaces, okay, and this has a value of these, but so this cannot get it out, okay. But so it tries to do a reasonable job of getting the values out and doing the parsing. So control. So you have for loops and while loops. These are the basic. While loops work in the usual way. Okay, so you say while condition. The syntax is very similar to C. So you open this round parentheses. The condition in JavaScript is inside round parentheses, right? And then you use braces to delimit control blocks. So that's what you do, and you use semicolons to separate statements. Okay. But of course you can also have empty statements. So in practice, people essentially put a semicolon at the end of each statement. You don't need semicolons at the end of braces generally. Okay, so similar. This is similar to C, right? So you sort of go a little bit fast. So, but you have your beautiful while loops and you have for loops. For loops only deserve one piece of care, which is the following. So you can have arrays quite easily. Var my array is equal to A, B, 3, C, D. Just to show you that this thing is not typed, okay? Fine. Now what is my array? Well, it's this. And now if I can do my array of 2, this has value 3. Okay, fine, great. Now, you can in this case, but don't do it, but you can say for var I in my array, open, I can write all on the same line. So I don't know how what happens if I change line here. But I can say something like a console.log, which is the way you log to the console. To log to the console, you have console.log for loggings, for routine messages. But then you can say console.error for error messages, console.info, console.warn, and you use these different levels because then when you look at the logs, you can essentially look only at some levels of importance, or they are marked in different color, etc. So when you look at your logs, you find what you want. But here is not important. Okay, so you can say console log my array of I. Something like this. Okay, so let's see what happens. So this seems to work. Okay, but in general, it's a very bad idea because the full story is that in JavaScript, arrays are not special. So in JavaScript, there is a notion of an object, and arrays are simply implemented like objects that have integer fields that have values. So an array that you would call my array is not really like what you would think in Java or in C as an array at all. It's like a hash table, it's like a dictionary basically, in which to the value 0 there is what did they put, an A, no? There is an A. To the value 1 is associated a B. To the value 2 is associated a number 3. To the value 3, and so on and so forth, right? But the problem is that this works, but you can easily add junk to an array. For example, I can say now, my array of, of George is equal to, I don't know, George IV. I don't know who he was. Okay, but this is something that I did, and this just works. So an array is not special. It's just like an object, and I can always define new fields of an object by just doing it. And now the problem is that if I do something like this, you know, this also enters the definition of an array. Okay, and the problem is that when somebody gives you an array in JavaScript, you don't have the guarantee that the person giving you an array in general hasn't given you junk in the array as well. Okay, so the way to iterate on an array is for var I is equal to 0, I smaller than my r dot length, I plus plus. So this seems very much C code, right? Console log my, well, I should have copied, right? Yeah. So this will give you the expected result. So please remember, when you have an array, don't ever iterate on the elements of the object, because there can be extra stuff. And it's one of the, at least for me, you know, because I'm so used in Python to be able to say for X in list, you know, and then I just write a code with that style. So for me, this is one of the biggest gotchas of JavaScript. JavaScript, as you will see, it's a nice language. It's very handy for many things, but has a certain number of traps. And one of the traps is this one, that for JavaScript, there is no difference really between an array and any other object, okay? An array is simply an object that happens to have integers mapping to values. Okay, so so there is no particular requirement on arrays, and so you need to iterate on them carefully, using the length and using an integer as iterator. Otherwise, you might iterate on whatever other junk the array might happen to contain. So after this parenthesis, let me go back. So this is a for loop. You see, this is done in a very similar style. Here the person says number is equal to number plus 2, but he could have said the number plus equals 2. Okay, so it's very similar to C, I guess. Okay. Then this is a loop. The odd thing is the equal. Here it's using a triple equal. The thing to notice is, and we will come back to this soon, actually in the next slide. So the problem is, one of the other gotchas of JavaScript, actually this is one of the biggest ones, is that it has implicit type conversion. So to try to help you, the idea is, okay? And these implicit type conversions are both great and the source of a lot of trouble, actually. So if you say 100 plus 1, as a string, this converts both to a string, because it knows that everything can be converted to a string, right? But if you say 100 minus 1, you know, minus between strings does not make sense. So JavaScript tries to be very helpful and says, minus is an integer operator, a numerical operator. Then let's convert both arguments to numbers. So you see, you have, I don't know if I can, let me give you an example of why that is so interestingly perverse. You know, I can have S is equal to 100, and T is equal to 1 as a string. Okay? But now you don't know what they are. Maybe they come from another piece of your code. And now you say, what is S plus T? Oh, great. And what is S minus T? Oops, different, right? And so one of the problems of JavaScript is that due to this implicit type conversion, you know, you have something that works, you do a minor stupid modification that actually shouldn't affect certainly the type of what you are computing, but maybe you should just affect, you know, the value in some way. and boom, you get something entirely different. You know, imagine that before you had s minus t and it was an integer and that's what you expected. Okay, now this is even more complicated because of you know, the varied way in which you might inject values in your JavaScript. Let me give you an example. Okay, this variable t that I have here, that is equal to the string 1. Maybe, you know, there is an input value in your code, one of these, you know, input tags, okay, and input. And so in this thing here, well, yeah, okay, fine, it could also be this way, but essentially this generates one of these input boxes, right, in which the user can type. And so this input box maybe is, you know, how many whatever, you know, how many days a week do you drink milk, whatever, no? And so you put an integer there, and when you write your code, you will tell JavaScript in a way that I will explain you next time, this time or next time, I don't know. But there is a simple way to say, hey, take this input field, take the value the user has typed, and put it into this variable. So in your mind, since it's the number of days in which the person drinks milk, you think it's a number, right? And you write your code, you subtract it from another value, and you get a number, and you're all happy. And then you decide, no, maybe I should add the number of days in which the person drinks milk. So you change the minus into a plus, and suddenly, instead of doing the right operation between integers, you do it between strings, because it didn't occur to you. But when you get a value typed by the user, you actually are getting a string. You're not getting an integer, right? And so these implicit type conversions, coupled with the fact that you do not always know the original types of the things, can create very complicated to debug consequences. Because it will, you know, may work for many examples, and then you, at some point, either the server or something else generates a data of a type you don't expect, and boom, you know, you get very strange results, and you cannot trace them, because often these kind of things happen in code that you have debugged already for a long time. That's one of the problems, okay? That this code has been running for a long time, and so when you do some other change that changes the type of a variable and you break something, it's sometimes pretty difficult to figure out what did you break, because, you know, the culprit is maybe some statement in some code that has been stable in your code for a long time. That's one of the problems, okay? So here are some other fun examples. Well, this is just the opposite, okay? And the same is for, yeah. So there is parse int and parse float functions if you want to transform things into integers. But here, you know, one is really missing the type checking that would tell a person, hey, you forgot to convert automatically. I'm doing it for you. I mean, it would be nice to have a version of JavaScript in which you can switch off these automatic type conversions. But the problem is that a lot of libraries rely on it. And so it's hard to, I mean, you cannot do it in that way. Now, another problem that is even sort of more interesting is that the automatic type conversions happen even when you compare things for equality. So if you use your trusted double equal that works in C and in Python, the double equal in JavaScript will try to do type conversion to try to see whether we can convert both arguments to the same thing. And you get the most odd results, including that it's non-commutative. For example, empty string is equal to 0. No, this is false. But 0 is equal to empty string. Why? Because the logic of JavaScript says, well, there's empty string, you know, maybe I can convert it to an integer of 0. Because, you know, that has 0, it's the null value, and converted to an integer, trying to be helpful, that's what it does. And then, yes, they actually are equal. And so 0 is also equal to the string 0. I don't know if the string 0 is equal to 0. Actually, we can try, you know. I have to tell you that I consider these things so crazy, and that I don't know them all. Because I don't think I would ever write on purpose. Okay, this is actually symmetrical. Fine, great. False is not equal to false, but false is equal to 0. False is not equal to undefined, but false is equal, null is equal to undefined. No? So you have all these possible crazy loops. So it's essentially very difficult to make sense of double equal, unless you know that So I'm not a language theorist for JavaScript, okay? I'm essentially a user of JavaScript. And so I tell you that my rule of thumb is that if I'm not certain that two things are of the same type, I basically don't exactly know what double equal will do. And so to solve this problem, there is something that is triple equal that actually tries to compare whether also the type is the same. And so, yeah, and then you can invent four tuple equal, right, or something like that. No, four tuple equal, not yet. But you know, computer science is similar to that. You know, there is a single quote, there is a double quote, there are the reverse quote, and if you gave them yet another type of quote to people writing shell languages like Bash, you know, they would have invented a purpose for it. And so here in JavaScript is with the equals, right? So there is always one more type. So essentially, if you're not sure what the arguments contain, use a triple equal is the morale. So you can define functions. These here we can define a function that is called power, okay, base exponent, and this uses iteration to compute the result, and this says return result, and this works. I don't know if I can. I'm not sure cut and paste works well. But let me try. Yeah, perfectly. Okay. So this works. What is the scoping? So, sorry. Let's look at this code. Maybe actually let's copy it. We define a variable top level, and inside the function, we define another variable, and we log its value. Okay? And in print variable, in test, inside the function test, the variable has value test. Okay? So essentially, if you have a global variable, and if you define a variable of the same name inside the function, which seems logical enough, you access the value that is defined inside the function. Okay, so you get the value from the closest scoping. Okay. Sorry. Sorry, I'm just going around in a bad way. Okay. Now notice the difference between these two. Okay, if you in this case, in the function test, you are declaring a new variable, in which case you get to the you define a new variable that has a scope inside the function. Obviously, if you forget to say variable, if you forget to say var and just say variable is equal to test, then obviously you are using the variable defined at the top level and you're just writing another value to it, right? So global variables are accessible inside functions. I mean, this shouldn't come as a big surprise in any way. So if instead we try this code here, okay, I wish I can just erase this way so it's cleaner. But if I try now, you know, the value is the same, obviously. I mean, I think it's obvious at least. Okay, so here there is some more about scoping. Essentially, we have a variable. And we define a child function, and we want to know the value of the variable inside the child function. Okay, so let's see what happens in this case. So if we do this, you know, the value is local. So essentially, if you nest function definitions, you are getting the value of the variable from the innermost scoping. Okay, which is sort of, you know, what you would expect that happens, I guess. Okay, there is more on scoping, but I'm sort of you know, getting semi-bored by scoping. You can look at these references further if you like. So now JavaScript is an interesting language because it has objects, but it does not really have classes. Okay, so in fact, anything that is not a basic data type, such as a string or a number or Boolean is an object. Okay, so arrays are objects, etc. And there is no multiple shades of objects or so. I mean, everything is an object. So this cat is an object that has, and an object internally resembles very much a dictionary. Okay, what in Python is a dictionary. But this similarity is mutual, because internally objects in Python bear some resemblance to dictionaries, right? I haven't told you all these things about Python because this class is not really about Python, Python internals. But in Python, there is also a way in which you can take all the fields of an object and you can treat them like a dictionary, mapping the field name to the field value. Okay, so you can do these transformations. But in JavaScript, it's particularly evident that an object is essentially looks like a dictionary and is roughly like a dictionary. Okay, so it has many fields and every field has a value. And even arrays, as I told you, are implemented as dictionaries between integer fields and values. So it's a bit of a strange idea. Normally you are used to dictionaries in which the key might be a string, but at least if you're used to objects in which the variables are strings, sort of, right? The object variables. I mean, they have a name. And in JavaScript, you can also have fields that are integers. So that's what you do for arrays, in fact. Okay. So this is a perfectly good object, and you can say cat.size, or you can say cat in parentheses size. Okay, in square parentheses. Okay. In Python, this is a notation that you need to define. Maybe one day I will tell you how, one of the other lectures. But in JavaScript, it's automatic. And so this works well, even in unexpected ways. For example, there is my array, right? And then I can do this, I guess. No, unexpected number. Oh, yeah, it's because it doesn't like the syntax, I guess. Yeah, that's the problem. Yeah, I would need to do this. Eh? Yeah, sorry. Fine. Yeah, otherwise it's a syntax problem, actually. You can delete elements of objects if you need with a delete. This might be useful if your field is particularly large and you want to reclaim it. I don't think I ever did it, but you can do it. Okay. You have arrays, as I mentioned already, so you can create arrays, by just using square brackets and putting inside the various elements in a list. Okay, and every array has something that is called the length. No, I can say my r.length. Actually, there are a lot of things defined here. Okay. George, all right, George, I defined it myself, but so okay, so if I type, well, this is my array, okay, and then I can say my array of 100 is equal to hello, okay, fine. My array dot length now is 101, but my array is an array of 101 positions. Okay, so, but this is what it contains. Okay, so the other values are undefined. Okay, my array of 7 is undefined. Okay, so and notice how helpful are these consoles in order to let you explore the structure of objects. This is incredibly handy, obviously, when you debug, because when you can just print a complicated object, and then in the console, you can unfold it and look at the various components recursively and look at what is inside. It's great, I wish all consoles were like this, obviously. Okay, so so let's go a bit ahead. Sorry. So arrays are just objects. Okay, so this is what an array is. This is what I told you before. Okay. Now you can attach functions to objects. So in JavaScript, functions are first-order citizens of the language, even more so than in Python, right? So you can say var rabbit is equal to an empty object. Then I say rabbit.speak. Rabbit.speak is a field of the object rabbit. Okay, and I can say that rabbit.speak is a function. that takes an argument line and then in braces you define the value of the function. That is something we will do quite a lot in JavaScript. So in JavaScript, defining functions on the fly, you know, on the command line or on the right-hand side of an assignment, or as a, you know, even as an argument to another function would be extremely common. And you do it by saying function, you put the formal parameters in parentheses, and then you write in braces the body of the function. Okay, so that's the syntax. Okay, so this semicolon here, okay, so essentially the function definition ends with this closed brace. And the semicolon there, it does not belong to the function definition. It's just, you know, the end of the line of the assignment rabbit.speak equals to. Okay, so we can run this code just for the fun of it and see. Sorry, I need to grab also. Let me clean up a bit. Sorry. Okay. You see, rabbit is an object that has a field speak that is a function. And speak is a function that if I open it, it contains this as prototype and, you know, gives me other information. Okay. I actually hadn't explored all these fields in a function, actually. It's the first time I do it. Okay. So, fine. So we have a function of rabbit. So we can define multiple objects, okay? So I can also define functions on the you know, not associated to an object. I can simply say function speak of one variable, a console log of that. So essentially I can define functions pretty much as you do in Python via def. And then if you define it this way, the speak will become, you know, the name of the function that is available throughout your code, okay? Fine, this is not so complicated. But then you can define objects that can refer to these function names. So for example, I define a white rabbit that has adjective white as a string, speak, where speak is this function. And a fat rabbit is an adjective fat and speak is speak. Okay, so you can define objects in this way. Okay, notice that we are creating objects without having the classes for these objects. Okay. So this is different, you know, from Python or Java. Actually, Python is a sort of way in between, because in Python, if you really wanted it, you know that in Python you can always define one more field to an object. I can always take a variable that is called, for example, a, and I can say in Python things like this. I can say class a of object. Okay, and then I say sort of def init self. Okay, and I can simply say pass. Okay, fine. So this is sort of, you know, the most stupid class I can have. I mean, in fact, I'm not even sure why I couldn't simply use object. Okay, but fine. I define this to avoid this useless class. Now I can say x is equal to a, and so I get an object in x. Okay, notice that x I haven't defined any value, any field for x, right? But nothing prevents me from writing x dot for foo is equal to 3, and x dot bar is equal to Joe, if I want, right? So so in some ways, differently from Java, in Python, you know, the fact, even if you have a class definition, this does not prevent you from adding fields to an object. So you know, Java is the purist language in which you need to define how objects of a class look like, and the type system tells you, you know, what the fields of an object should be, and etc., and you can inherit and yada yada. In Python, instead, the notion is loose. So you can define a class, and when you define an object of that class, the initializer for the class will be run, and so some of the methods, some of the object fields may be already present in Python. Okay, so for example, here I could say instead of pass, I can say, for example, self dot foo bag. What are the self on foo? I don't know. Self dot my x is equal to 7. No, whatever I want to write. Okay. So, but Python really doesn't care which fields are initialized as part of a class initializer and which you later add. Okay, and JavaScript, if you will, it's even more extreme than that, in the sense that it doesn't even have an initializer. You just create an object and then you put the fields inside the object itself. Okay. So, okay, fine. So now we have these white and fat rabbits that are just two objects. And so I can do this interesting thing. I can define a function that refers to these. Okay. And if I use the new keyword in front of it, this enables me to define a function that will generate objects. So, you know, normally in Python, we would have a class. A class is what generates objects to us. In JavaScript, there are no classes. So how do we generate objects? Suppose we want a lot of rabbits that differ only by the adjective. It would be kind of boring to have to say each time we want a new one of these rabbits to say, adjectives is equal to these and function speak is equal to these, right? So it would be a lot of repeated code. So instead we can do it in this way. We have a rabbit generator function that takes an adjective and builds the rabbit object around this adjective. It says this dot adjective is equal to adjective. This dot speak is equal to you know, the function we wanted. We could have defined this function also outside if we wanted, right? But this is our choice, basically. It doesn't matter so much. And now we can say var killer rabbit is equal to new rabbit of killer. Okay, and now we get a new rabbit that has an adjective killer. Okay, so we can define functions to generate objects on demand. Okay, and not the use of this keyword. This refers to the current object. Okay, so essentially the new generates a new object, and then rabbit will use the these in order to build the fields into the new object. Okay, so now if you think that this is unpleasant, you can also do the following. You can also say, define prototypes. Okay, so you say a function rabbit of adjectives, this adjective is equal to adjective, but rather than specifying as we did before this dot speak, you say rabbit.prototype.speak is equal to function, and you say what it is. Okay, so this use of the prototypes is used to specify essentially default values for the object. Okay, so in Python we would have put these things in the initializer method. In JavaScript, you can either put them as additional statements of the function that actually builds the object, or you can put them as prototypes. Okay. Okay, so so this is a sort of pictogram of how this works. Okay, so how can we do more complicated chains? Okay, so yeah, these are things I actually, you know, don't think I ever do, but let me decode this code for you. So you can define an array. And you can say array prototype head and array prototype tail. Okay, so this is called monkey patching because of these. normally you would define the prototypes before you define the objects. That's sort of what kind of half makes sense, okay? But here you can actually define the prototypes after you define the objects, okay? It's as if, I mean, it's a crazy thing. I don't know how to define it well, but it's as if, you know, dynamically, after the objects exist, you say, oh, really, but the initializer contains something extra, okay? And this is really powerful, and yeah, as well really dangerous, right? Because you're then changing the definition of all the objects that have been declared with that prototype, okay? So you see here, there is an object that has a type array, okay? So there is a function array that comes with some content, you know, there is length, etc., etc. And here we are essentially adding prototypes to the array, so that the array will have extra methods that are available to us every time we actually have any array, not only arrays we generate, any array that comes to us, whatever way it comes to us, okay? So, and now we have a function head that will tell us the first element of the array, and the tail function that will give us, you know, everything after position 1, okay? So, okay, and so roughly this is a very, very quick introduction to JavaScript. I think this is all I want to say for the moment. I think the other portions we will see them later as we use them. But JavaScript is essentially this. If I were to make a summary, it's a scripting language in which you have objects. In fact, everything is an object aside from the basic data types, but you do not have classes. You can generate many objects of the same type, either by a function, I mean by a function or using the keyword new, and you can define prototypes that are an easy way to say all the properties shared by object of a certain generator, okay? Moreover, you have to be careful that there is automatic type conversions in JavaScript that affect both the behavior of equality and the behavior of you know, the basic operators of the language, like plus, minus. And those are, you know, causes of great, many bugs come out of those, essentially, okay? And I think this is a super quick introduction to JavaScript will do. At this point, I would say that more than half of JavaScript is the flavor of how it is used in practice, okay? You will see it's a very different language, and you write code in a very, very different way from any other language I've seen. I mean, not entirely, but in some very important respects, the code will look very different due to the way you use it, okay, not due to the language itself. And so I think now I want to do some more examples in which we build things in JavaScript and I show you how to actually embed it and use it inside a web page, okay? But now let me do a short break and take questions, etc., and then we begin again in 5 minutes. Are there any questions before we break up on this language, actually?
So if I compare my variable to another variable, my variable then become that type or
Something would be saying.
if I use a double equals to compare like that variable to something else,
No, the type of the variable is not changing. It's, you know, on the fly type nasty, but from the equality operator. Yeah. No, that would be even nasty, right? Yeah. Yeah. But I think how you never go, I guess. Yeah. So no, it's not nasty at that point. I should add another reason why JavaScript is becoming very popular. One reason I will tell you when we start using it, because otherwise it's not obvious. But another reason is this: browsers depend on JavaScript, and so much effort has gone into optimizing runtime execution of JavaScript that it has really become quite efficient. So it's way more efficient than many alternative languages. Not because it lends itself to efficiency. In fact, it does not, probably. But there was such an enormous effort among browser vendors, you know, and browser coders to make execution of JavaScript as fast as possible, that really now it has become a very fast language. Any other any question so far on this language? Okay, so let's yeah.
What does it say to avoid that?
Yeah, many people say to avoid that, you know, and I think I already told you that I'm a sort of cowboy that, you know, gets information from every possible path and I can care less whether it's pure or not. You know, I'm a sort of, you know, garbage eater of information. Now, the point is that these W3 schools are not, you know, the official source of the information. And so they contain some very subtle things that might be wrong. But in practice, I don't care so much.
I tried to use W3 schools when I first learned JavaScript. It doesn't explain anything. It's just like, here's an example. Try this out. It doesn't explain how anything's working under the hood. And I was just utterly confused and extremely frustrated at it. I can say that from experience, W3 schools is terrible.
Okay, maybe, you know, our difference of opinion perfectly matches. The reason that I like it is because I go to it when I want to see an example. And so for me, it works in that way, right? And this, by the way, is an interesting thing about documentation. Yesterday, I had some people who came to my office hours, so they wanted to implement a calendar in their project. And so I started looking around for calendars, and I found this visually incredibly beautiful and flexible calendar that implemented in JavaScript, so that you could, you know, via JavaScript, ask the server what are your events on the calendar, and then it would, you know, display them very nicely, etc. And it was beautiful, but the documentation made me realize one thing. A lot of people believe that in order to document a piece of software, and this is an incredibly common belief, you know, even when I was working at Google, everybody believed that. They believe that in order to document a piece of software, what you need to do is to explain in detail what each method does. And this is crazy. I think that that kind of information is sort of legal information almost, that, you know, yes, it should be somewhere. But the documentation that is most useful, that everybody wants to find, is not that. The documentation that people want to find is examples of how things actually work. Okay, and for example, that calendar, to me, I mean, I hope that I can decode it, but it was unusable, because what did I get? I got 100, not kidding, 100 of possible method calls, so that each one of them would do one thing, like, oh, this is the description of the event object. And the event object was this way, you know, has a starting date, a stopping date, and therefore say, I could care less about these. Just tell me just give me an example of the format in which these events are, and what do I need to write in order to fetch them. That's what I care about, okay? And so, you know, they say that the unit tests are useful in to debug your code. That's another complete bullshit, frankly. Unit tests are useful for two reasons, okay? Unit tests are useful, first, because they act as documentation. If you do a unit test for your calendar, I can go look at it and then say, oh, that's how he actually calls it. Because the unit test has to work. And so now I see a working example of how to set up a call for your function. I mean, this might seem trivial if your function is trivial. But I remember at Google, you know, reading some documentation that was utterly incomprehensible about how to, you know, access one of their data stores. And you couldn't make head or tails of it, because, you know, again, a gazillion methods that each one would do something. Then instead, you look at the unit test, and the unit test has to build a working connection to the data store, right? Because it has to test it. And so you see, these are the three calls you need to set up the connection and how you actually call it to get something done. And you use that. So documentation is one of the reasons. And the other reason for unit test is to avoid other people breaking your code, and you have to cope, and you're having to cope with it later. So this is a social purpose. But suppose you write some code and it works. It generally works after you finish writing it and testing it. Okay. Suppose you don't write a unit test. Then, you know, somebody else comes. You know, you come and you write your beautiful code, and you don't know it, but you break my work, and you don't know it, right? I don't realize it, and, you know, 2 weeks afterwards, my code is broken. And what happens? Then, you know, I get scolded, essentially, you know, and I get told, you know, fix it, you know, it doesn't work anymore. And maybe he broke it in a pretty serious way. So I have to go through hoops and hoops and hoops. First of all, in figuring out how he broke it, and then in fixing it. So it's really hard. Okay. Instead, if there was a unit test, when he tried to check in his code, he would have broken. And then it would have been his responsibility, not mine, to make sure that my code is not broken. So essentially, these are the two real uses of unit tests. And I don't think that, I mean, were you taught that these were the uses of unit tests? I don't think so, right? I mean, the official software engineering is that they're good because of debugging and testing the code. And I don't think it's true. If I am to test my code, I'm just faster by writing some very quick test harness. I don't need to freeze it in a unit test that stays with the code. Okay. Okay. Sorry. Outburst of what I think is the hidden truth in software engineering. Now let's take a 5-minute pause. Yeah, but no, but that's really prepared. No, I mean I can start a jQuery, I guess. It's only that I haven't written a while in jQuery. What should you do? What's a simple example initially? I'm not sure. We could add and remove classes from objects depending on what you do. Then we can do automated form submission. Yeah.
Automated form submission.
Sorry?
Automated form submission.
No, but maybe I want to do it later because do you remember all the details of how to do this? I mean, I have some code samples that I use generally, and I don't want to do it without.
I usually design samples and I just make changes on those.
Yeah, no, let me maybe do it a little bit. Do it a little bit later. Yeah, I should have prepared that. But last year this took an entire class.
Anything else?
I mean, we could actually write some code freely now in JavaScript. Maybe that wouldn't be such a bad idea.
I think that should be fine.
Okay, maybe let's start again. So what do we do? Okay, when you use JavaScript in the browser, you use it essentially in the following way. The browser parses a document and creates the internal pass-through of the document. And then you use JavaScript to affect that tree in one way or another, and to also store internal data and communicate with the server. But so there are two ways of referring to this tree. You can do it directly But unfortunately, when browsers were originally designed, each browser had a slightly different way of representing the parse tree. So there are some details that are different from browser to browser about exactly how the tree looks like and how you walk on the tree that represents the current document. You know, for example, suppose that you have a web page and now you want to say, quick, get me all the images that have this particular class. Okay, so you need some way of doing this. And this is not necessarily, it does not necessarily behave the same on all browsers. So in order to cope with this difficulty, there is a very well-known library, okay, that is called jQuery, that builds a layer of compatibility on the various browsers and gives you some methods that will work in the same way from browser to browser. Okay, so this is one of the things that will change in time. I'm sure that 10 years down the road there would be something else than jQuery. But right now, jQuery is one of the most pleasant ways to have your JavaScript interact with the browser. Okay, it gives you a level in which the JavaScript can refer to the structure of the page in a pleasant way that is portable from browser to browser, so that you don't have to worry about your code working in Chrome but then breaking on Firefox as much. Okay, so some things might break. The CSS is not the same, but at least the code path will be relatively stable. Okay, so and Web2Py comes with jQuery already enabled. Because it is so common, in Web2Py it was decided to give it available already. So these are my applications in Web2Py. Sorry, I'm going around. So let me close these. Okay. We can create a new application, for example, I don't know, JS example, okay? I don't think it created it. Okay, great, and now we can edit it. I prefer to edit it from Eclipse. Okay, it's here. Okay, so let me first look here in the views layout.html. Okay, so if you look here, at some point, sorry, let me just search because it's faster. There should be the jQuery library. Why is it not here? I think jQuery is loaded even if I don't uncomment these. This is only for jQuery UI. So there is a. Let me show you the documentation for jQuery, by the way, since we have at it. jQuery is documented here at jQuery.com. Okay, and here you can find essentially all the documentation of the APIs that you can use. So the API is quite large, and we will have occasions to explore it. There is another thing, separate thing, okay, I mean a sort of additional plugin module that is called the jQuery UI. And this is jQuery UI, and jQuery UI is a set of interactions implemented in jQuery in JavaScript. For example, one of them is draggable, okay? This is something that you can drag around, okay? And the beauty of jQuery UI is that if you wonder, how this works, this is the source code to implement it. And it tells you each time exactly what you have to do in order to implement. These 27 lines implemented this draggable piece. Okay, and so if you look at the code, you will see that it will load jQuery, and it will load jQuery UI. So jQuery is the basic compatibility module with the browser, and jQuery UI is a library on top of it that gives you a lot of useful animations. Okay, so you load the both, and then you simply say, this is you simply say this. This is the important part. Okay, you say that we will decode it in a moment, but you say that everything that has a ID draggable should be draggable. Okay, we will go to it later, but I just want to show to you these are the resources. Okay, this is jQuery UI that you should explore for your project because it gives you a lot of elements you can use, and this is the jQuery library per se. Okay, so what is the idea? Once you use a jQuery, let me go to the sort of default index page so that we can play a moment. We will be playing mostly, now on the browser side. So we are not so interested in controllers now, but we're interested in the pages. So I go to index, and as usual, I sort of nuke everything that is in here so that I get a simpler page. Okay, so let me just check that this works and I can load it. Sorry, I want to view it. Yeah. Okay, fine. Okay, so I don't like this right sidebar. Maybe like this it will be better. No. Ah, okay. Ag. Oh. Okay, fine. What if I eliminate this entirely? Great. So now we have an empty canvas. So you remember. Okay. So I'm just thinking at how to make a simple example. Okay. Okay. So let's just write a very simple content. I want a list with the 2 elements. Okay. So and because we are just playing, I'll make it very simple. So and I say first and the second. Okay. This is super simple. If I display these. Yes, because I should have done it in this way. Okay, fine. Very simple. Now, what does jQuery do? Or how can we use it? So, first of all, where do we put the JavaScript code in the web page? And this is an interesting problem. Let me. We can put it inside script tags. And let me add here some code. Then we will discuss what the optimal location is, okay? And imagine that all I want to do is I wanted to, okay, let me add a button that doesn't do anything. Okay, so this sort of doesn't do anything. Let me, okay. And this doesn't do anything because I haven't defined where it leads, so it doesn't lead anything to any place, okay? So let's do a simple application. When I click the button red, I would like the first of those 2 lines to turn red. Okay, that's something that I might want to do. Just to give you a super simple example of how to use a JavaScript to intercept an event and do something on a web page. Okay, how would I do this? So you know that with the CSS, I can define I can define essentially classes. I mean, I can refer to elements in the page. And the same is in JavaScript, okay? So I want essentially to do this. I need to define a click listener on the button, okay? And when the button is clicked, I want to do various things with it. So I want to listen to this particular button. I will put also another button, okay, here that will say, for instance, blue, okay? So how can I listen to when you click one of these buttons? This will work similarly to JavaScript. Similarly to CSS. So I have these selectors, and in particular here, because these two buttons are of the same class, I cannot distinguish them by the class or by the fact that they're buttons. I need to give them a different IDs so that I will be able to know which one of the two I am actually clicking, okay? So I would say ID is equal to button red, and here I will say ID is equal to button blue, okay? Yeah, because this is Python equivalent, you're right, thank you. So if I do this, and I reload the page, obviously, okay? If I look at the page source, oh goodness, no, that's not what I wanted to do. If I wanted to inspect the element, if I inspect the element, you see that the IDs come out in the way I want, okay? And then there is this empty script afterwards that I haven't defined yet, okay? Good. So now I want to define, I need to do various things. First, I need to fish out one of these buttons to attach an event listener to it. I told you last time in informal ways that when that event listeners work in this way. To the hierarchy of the parse tree of the HTML corresponds a hierarchy of elements on the page that really occupy an area on the page, right? So you have a button, the button might live inside a div, and the div might live inside something bigger, etc., etc. When you do an interaction with a web page, you always trigger the event on the innermost possible element, okay? And when you handle this interaction, you either define the effect on it immediately, you either, I mean, the browser looks for event listeners that are attached to that element. If it finds one, it runs it, and if it does not find one, it bubbles the event tag, is called, to the next enclosing element, and it will look there, okay? So it will look essentially in the whole hierarchy of elements, and at the end, it will look for event listeners defined on the whole page, okay? Now, this is very useful, but in this case, we don't care about the bubbling up so much, because we will define an event listener that is defined right there for the specific button, which will be the innermost element. That's because, this time is what we need to do is that. So how do we, there is this parse tree that corresponds to the page. How do we refer to elements of it? Now, jQuery helps us by giving us, you can call it jQuery, and some people write jQuery, but a shorthand is to use simply a $sign. So what you do is you write a $sign and open and close parentheses. And inside of these parentheses, you put a selector that is essentially the same type of selector that you would put inside the CSS. So here we want a button with ID button red. So we simply write be red, okay? So this is a selector that selects all the elements of a page that are ID be red. Well, because this is an ID, there will be only one such element, okay? But you can also select for classes. For example, if I selected the BTN, this would be a jQuery selector that would return. This is like a function, okay? It's a function that takes the selector string and returns to me a list of elements of the page that match that description. In this case, I would get a list of length 2 that contains the 2 buttons, okay? But if I do this, I just contain a list of length 1, which contains only 1 button, okay? Now, here, we need to define an event handler for click, okay? So how do we figure out what are the event handlers? Well, if we go to the documentation, I want to show you a moment. You see that there is a whole section on events and browser events. So you can look under browser events, yeah, sorry, things are mouse events is what we want. I'm sorry. So click, there is click, double click, focus out, hover, mouse down, mouse enter. There are a lot of them, okay? But the one we are interested in using is click. And so if we click on click, sorry, I mean, if you select click and look at the documentation, it tells us the following. I think it's useful to look at a few of these documentations to know how they work, okay? Click, dot click takes a handler. And the handler is a function that will handle the event and do something as a consequence to it, okay? So this is an example. You see, dot click takes a handler, which is a function that will get the event E as the target. Why don't I use the event E here? Okay, they use these. There is more than one way of doing it, I guess. Sorry, I'm just looking at other examples. Okay, so we can do click. So this would be the statement. Okay, this is a JavaScript statement, and inside here we say that when you click, we do a function. Okay, and so this is a very common parenthesis that you will see in JavaScript, in which you close both of the function that is the argument and the argument list. Okay, so inside here we are writing a handler, and what do we want to do in this handler? Well, we can do what we want. For example, we can do console, just as an exercise, log the click is detected. Okay, let's see a moment how this works. Yep.
You didn't change the name back to B-Writer.
Oh yeah. It would not find it. Thank you very much. Okay. So sorry, this is my page. So I view JavaScript console. Okay. Let me put it back in so that we can see it side to side. Okay. So now if I click here, sorry, I should reload the page, of course. Okay, this click is detected, and if I click here, there is no click detected. Okay, it tells me 2, 3 because it doesn't want to repeat the message each time. There are messages that are repeated. Okay, fine. So we can do the basic. Great. Now, instead of doing this console log, I can comment it out, I guess. But what I want to do now is to turn the first string red. Okay, so I could turn it red brute force, but that's not what people typically do. What people typically do is this. In a block, maybe it would be better block head. So in the header of the file, and if I don't make mistakes, we can have a style block, okay, in which we can say this. We can say that everything of class color red, okay, is of color which is red. Very, very deep statement, I guess. Okay, but in this way we have defined a class that has the effect of coloring stuff red. And what we will do, this is a very common paradigm. What we will do from jQuery is that we will want to say, hey, fish out that first line and add a color red to it. And add the class color red to it. Okay. So again, to make it simple, I will attach an ID here because I need to decide how I want to decide, the target of my actions. So here I do ID is equal to first line, and here I do ID is equal to second line. Okay. So here in the handler I do this. I take first line, Okay, and so you see this dollar and in parentheses first line will return to me the list of all the elements that match the selector. The selector works just like CSS, so it will select all the elements of ID first line, okay? And now I can apply functions to it. And there are many functions defined in jQuery, so many that I certainly don't know them all. But a common function is to add or remove classes, okay? And if you want to look it up in the documentation, which is a useful thing to do, well, okay, I don't know exactly in this documentation in which place it is, but essentially is jQuery add class. Okay, so it would be here. Okay, you call add class on an object, specifying the class name you wish to add. Okay, so here you say add class, and so sorry, just but to continue. You see, this is one of many functions that are part of the manipulation of the tree. You have add class, you can append content, you can append HTML to something, you can change attributes, you can clone, you can get the value of CSS, you can remove all the content, you can do a lot of things. So essentially JavaScript enables you to have JavaScript and jQuery let you modify the parse tree of a page dynamically in any way. And there is something hidden in it that maybe is obvious to you, but I still want to underline. So you have the browser that has parsed a web page and has a parse tree inside, and now you are modifying the parse tree. In a lot of similar cases in computer science, you modify the parse tree and nothing happens because the parse tree has already been rendered. But that's not the way it works in a browser. A browser implements the parse tree with listeners. The browser is continuously listening to changes in the parse tree. And if you change the parse tree, the browser will retrigger a rendering that will represent the changes to the parse tree in the browser, right? So there is a whole infrastructure there that, to us it will sound quite obvious. Oh yeah, I add the class to that element. But in fact, it's via a sequence of listeners that the change will be reflected on the web page that is visible to the user, okay? So at any rate, now we added this class, and the class is called color red, okay? So that's all we need to do, actually. Sorry, I have this confusion in where I need to be. So suppose I reload this page, okay, now I do this and it becomes red. Okay, great. This is a great victory for now, okay? And now, if I want to do something else, for example, I can do this. I can make sure that when you click on blue, instead of just the first line, maybe I'm a bit bored, and I say that everything that is an li elements inside a UL, these are generic CSS selectors, and I can add a class that is color blue, okay? And here I can define a class color blue just quickly. Color blue, and I add the color blue to both, okay? Something like this. So you see that that one of these things can return multiple elements, really. So I need to reload. So the red works and the blue works as well. Okay, and I can do this. No, okay. So why doesn't this work? Okay, well, why doesn't it work? Yeah, good question. Let's inspect the element. Okay, and if we inspect the element, we see. It's actually very interesting because if we inspect the element, we see not the page as we loaded it at the beginning, but we actually see this effect of having added the classes, right? So we see that the problem is that this class has both color red and color blue. So that's not a great idea, it's because we are adding classes, but we are not removing them. And so essentially here in the styling, you see that color red has been overridden by this later color blue class that has also been added. They both define the color, so only one of them can act. So that's not very good. And so if we want to fix this error, what do we do? Well, we go here. There must be a remove class method. So we go remove attribute, remove class, removes a single class, a multiple class, or all classes from each element. Remove class, add class. Okay, and maybe here I can also say remove class. Okay, and I can change them in this way because the result of this is another object. So at least I think so. Okay, I'm pretty sure. So let's load this up again. Okay, now I can turn the red, and I can turn blue, and now I can turn red, and now things work in sort of the way I expect them to work. Okay, fine. That's very nice. Now let's try another thing. Ready for some craziness? So yeah, this is a good idea, but you know, isn't it a bit bad to have this script here that sort of floats inside my HTML? You know, I put the style on top, but let's put also the script on top. No? So I remove it from here, and I just put it here in the head of the document, right? This seems to be a better place, more in order, right? So we do this, and then let's see what happens. I reload the page, and nothing works. Why? So the reason why nothing works is that there is a difference in the way you load web pages and the way you compile programming languages. When you load a web page, the web page is interpreted and parsed on the fly. Okay, it's not first of all of it loaded and then it's parsed and you know, and there goes this subsequent processing. The goal is that browsers want to be able to render the page as quickly as possible, and they don't want to wait, and even for the whole of the HTML to have arrived to start rendering. Okay, so if I do it in this way, what happens is this: that the browser will start reading what comes to it on the fly, and it will say, okay, style file declarations, these are great, thank you, you know, and I now define my CSS for these, you know, dot color red and dot color blue. Thank you very much. Then it goes and it executes this script, and this script says, hey, take all the elements of ID bread, and you know, apply to them this click listener. Only there is no such element yet, because you know the browser has not yet parsed the rest of the page when it arrives there, right? So it sort of sees that declaration and says, you know, and now what? You know, you know, fine. I don't have any element of type bread, so nothing to do. Thank you very much. And continues. Nothing of the. I have nothing with IDB blue. Goes on, and then it renders the UL with the two LI elements in it and the two buttons, and that's it. No click listener is ever attached. Okay, so essentially you have to be careful that the JavaScript is interpreted when it is parsed in the course of getting the page. Okay, not afterwards. It's not like a compiled language in which you know, I learned how to code in such ancient languages that I'm always surprised that I can say def like call f in a program, right? I can say like x is equal to f of 3, and then below I can say def f of x and say what f is. For me, the idea that the computer is smart enough to look ahead for the definition of functions that haven't been defined yet, it's not obvious, okay? Because, you know, ancient languages didn't used to do this for you. And I think that JavaScript in this sense is a bit like an ancient language, okay? So it really is defined as you read the page. So how do you solve this? There are two solutions. One is as I did, that is you put the JavaScript at the end of the page. It's not pretty, but it works. I mean, it is maybe not so terrible, okay? But it works because it's executed when the rest has been passed. But there is also another way to do it. Because often, you know, when you write a lot of JavaScript, it's really better to actually put it on top of the page and maybe include it from a file, right? And so you would like to include it from a file in the header of the page, but you want to tell it, you know, wait a moment, you know, don't start running or don't start trying to do anything until actually the whole page has been loaded, okay? And so the trick is this, that jQuery has an event that says, that tells you when the document is parsed. And you can listen to that event and run your JavaScript only when that event is detected. So look here a moment, okay? When there is we say .click function, okay? Inside of that function is run when the click event is detected, right? And so we now do a very similar thing to detect the loading of the document. And it is called document.ready, okay? So if you, well, it's one of the events, but let me just Google it for document ready. Okay? So you do this. Let me do it for you here. This is simply a selector that selects the whole document. So you say, to the whole document, now I attach this listener that is called ready. Okay, so I think we will have to close these parentheses, okay? And inside here, what do? We define a function, okay, that is executed when the document is ready. Okay? And so we do this. Okay, so we, I mean, I should have changed the indentation, but let me not do it. So if we go back, now if I reload this page, okay, when I click on read, everything will work. Essentially because it has waited to interpret the JavaScript until the page had terminated loading. So this is a very, very common paradigm that you will see. Okay, this document ready, and inside of the document ready, you have this function that is activated when the document is ready. And essentially, here goes what you want to do once the page has loaded. Okay, so this is a super quick introduction. I should indent this better. I'll do it later before I post this app. Okay, but this is a super quick introduction. So you see that how in JavaScript it's a very common practice to define functions on the fly. Okay, it's very common to have to pass functions as arguments to other functions. So in this case, the event listeners want a function to run. Okay, and so you create on the fly a function and you pass to it. And okay, so so this is JavaScript plus this jQuery interface to listen to events and to refer to elements of the parse tree. And you know, next time we continue and we do more examples of things we can do with the jQuery and JavaScript. Okay. Questions, or I mean, we're kind of out of time, I guess. But so next time more of these, and next Tuesday Patrick Rogers.